Hi class, and welcome to our video lesson on the Pythagorean Theorem. The Pythagorean Theorem is arguably one of the most famous theorems in all of mathematics. People remember this one more than any other theorem, probably in all of geometry. So I'm going to kind of write this as an if-then statement. If a triangle is a right triangle, as you can see there's a 90-degree angle, so this is a right triangle. If a triangle is a right triangle, then a squared plus b squared equals c squared. That equation we're going to use for the rest of the year. So let's make sure we're familiar with this equation. A squared and b squared, a and b are called the legs of the right triangle. So here's a leg and here's a leg. If we square both of those sides, it equals c squared, and c squared is the hypotenuse. The hypotenuse is the longest side of the right triangle. It is always located opposite of that 90-degree angle. So find that 90-degree angle. Opposite of that, you'll find the hypotenuse. So that goes on the right side of the equation. The legs go on the left side of the equation. So as a conditional statement, if a triangle is a right triangle, then the conclusion, the two legs squared, that sum equals the hypotenuse squared. So a squared plus b squared equals c squared. Let's see how we can apply this. I have two sides of a right triangle. If I have two sides of a right triangle, I can always find the third by doing the Pythagorean theorem. So the first thing I do is I locate my 90-degree angle, and opposite of that 90-degree angle is the hypotenuse. And that goes on the right side of the equation all by itself. So 13 squared goes on the right side. The other two legs, their sum squared goes on the left side. It doesn't matter if you do 12 squared plus x squared or x squared plus 12 squared. So there we have a squared plus b squared equals c squared. Now we're going to solve for x. So x squared plus 12 squared is 144. That equals 13 times 13, which is 169. Solving for x, I'm first going to subtract 144 from both sides, and I get x to equal 25. I'm now going to solve for x by doing the opposite of squaring. To get rid of the square, I square root. So when you square root, you get x by itself, and the square root of 25 is technically plus and minus 5. However, in geometry, these are lengths of a triangle, and so we would never talk about a negative distance. So it's fine if you just have x equals 5. And we would label x equals 5 centimeters. So if we had a 12 centimeter piece, a 5 centimeter piece, and a 13 centimeter piece, if we connected all those lengths together, we would end up getting a right triangle. Let's try this next one. So it's again a right triangle, and if I know two lengths of a right triangle, I could always find the third by using the Pythagorean theorem. So opposite of the 90-degree angle is my hypotenuse, and I know that goes on the right side of the equation all by itself. So y squared is on the right. That must mean that 13 squared plus 15 squared goes on the left side. A squared plus b squared, those are the two legs, 13 and 15. Y is the hypotenuse. Let's solve for y. 13 times 13 is 169. 15 times 15 is 225. And that equals y squared. When you add up 169 and 225, you get 394. So 394 equals y squared. So now to get y all by itself, we simply square root both sides. And when you get the square root of 394, when you put that in your calculator, you get y is approximately equal to, those two squigglies mean approximately equal to, 19.85. And this is, again, our units are in feet. So our instructions here at the top says find the exact value and find the approximate value. We have found the approximate value. This is the approximate value. To find the exact value, we had to round this 19.85, so it's not exactly 19.85, it's about or approximately. If I wanted to find the exact answer, I would break down the square root of 394. So this is what we did in the past few days, where we tried to break down this radical by seeing what perfect square goes into it, or you could use prime factorization to find this out. However, there is no perfect square that goes into 394. So we're just going to leave it as the square root of 394. Y equals the square root of 394 feet. So the second one right here, this answer right here, that's the exact value. The 19.85 is the approximate value. All right. So now that you know the Pythagorean theorem, when I wrote that as an if-then statement, the converse is also true. So that means the converse, the conclusion would come first. If a squared plus b squared equals c squared, then we have a right triangle. So I'm not saying that we have a right triangle right now. If we do have a right triangle, then a squared plus b squared equals c squared. So let's see if we have a right triangle using the Pythagorean theorem. So I'm going to use these three lengths, and I'm going to put them into the Pythagorean theorem. If the left side equals the right side, then we have a right triangle. So again, the hypotenuse always goes on the right side, and the hypotenuse is always the longest side of the triangle. So let's put the longest side between 21, 35, and 28. Let's put that on the right side all by itself. 35, you're going to be the longest side, so we're going to put you on the right side by itself. The other two sides we're going to put on the left side. 21 squared plus 28 squared. Now we're not saying that this is a right triangle. We are seeing if it's a right triangle. So we square 21, and we get 441. We square 28, and 28 times 28 is 784. And that equals 35 times 35, which is 1225. Is this a right triangle? 441 plus 784 is 1225. Does that equal 1225? If the left side equals the right side, yes, this is a right triangle. How do we know it's a right triangle? Because a squared plus b squared equals c squared. I ask you this question, everybody. Can these three lengths, can you put them together to make a right triangle? Well, we would have to see, does a squared plus b squared equal c squared? If a squared plus b squared equals c squared, then we have a right triangle. So I want to set this up using the Pythagorean theorem. So I want to again put what's acting as the hypotenuse on the right side of the equation and the legs on the left side. So the longest one has to go on the right side. So which one of these lengths is the longest? 2 root 2, root 24, or 4? Well, if you're kind of unsure of this, you can kind of approximate this one. This one is roughly 5. Square root 25 is 5. This one may be a little bit harder to approximate. It's like 2 times 1.7 or something like that. Root 2 is like 1.7. If you want to, though, you can just put all three of these in your calculator and see what you get. So 2 root 2 is this number, 2.8. And root 24 is that number, 4.9. And then obviously we have the 4. So which one's the longest? This one. We're going to put that on the right side all by itself. So root 24 is going to be our c squared, and our a squared and our b squared are going to be 2 root 2 plus 4. So a squared plus b squared equals c squared. Let's see if the left side equals the right side, shall we? When we take 2 root 2 and square it, 2 root 2 times 2 root 2 is 2 times 2 is 4. Square root 2 times square root 2 is 2. So 4 times 2 is 8. So this number right here equals 8. And then 4 squared makes 16. Does that equal root 24 times root 24? Remember when you take a radical and you square it, the radicals basically cancel out and you just get what's underneath the radical, which is 24. Root 24 times root 24 is 24. So does 18 plus 16 equal 24? Yes, it does. These three lengths are also a right triangle. So that leads us into what a Pythagorean triple is. A Pythagorean triple is three whole numbers that satisfy a squared plus b squared equals c squared. So the whole numbers are kind of like our counting numbers. They're integers. There's no decimals, there's no radicals, and they have to satisfy a squared plus b squared equals c squared. So a few examples of Pythagorean triples would be like the 3, 4, 5. We kind of, if we took 3 squared plus 4 squared, it equals 5 squared. 9 plus 16 equals 25. 25 equals 25. These are three counting numbers, whole numbers, that satisfy a squared plus b squared equals c squared. We had another one in our notes, the 5, 12, 13. We had that one in our notes earlier today. There's an infinite number of them. There's the 6, 8, 10. There are many more that you'll see as we go through this chapter of Pythagorean triples. We could also think of some non-examples of Pythagorean triples, such as 0.3, 0.4, 0.5. Even though these three satisfy the Pythagorean theorem, they're decimals. So decimals do not satisfy this whole number aspect, right? It has to be three whole numbers that satisfy a squared plus b squared equals c squared. Our last one right here, these three lengths satisfy a squared plus b squared equals c squared, but they're not whole numbers. These are radicals, which are irrational numbers. They're not whole numbers. So in order for it to be a Pythagorean triple, it has to satisfy a squared plus b squared equals c squared, and they have to be whole numbers. All right, let's do our last two examples here from our notes. If we have one that looks like this, I want to find this length. That's x. But I can't find that until I first know this length, because then I can do the Pythagorean theorem. So I first want to find this one, and that's called y. We'll call that y. So I could say, here's a blue triangle, and it's a right triangle because these are 90 degrees. So that means this would be 90 degrees, and then of course this would be 90. So the blue triangle is a right triangle. This side is 68 because it's really a square right here. And then if I took 82, this whole length, and I subtracted 68, I would just get this piece right there. And so that would be 14. So now I can do the Pythagorean theorem to find this green length, which we called y. So y would be the hypotenuse. It's opposite of the 90. So y squared, that equals the two legs, 14 squared plus 68 squared. So now we're going to solve for y, which means that we would get 14 squared is 196 plus 68 squared, which is 4624, and that equals y squared. We add these two up, and we get 4,820. That equals y squared. Okay, now we're going to square root, and we could reduce this radical, but for now, let's just keep it as the square root of 4,820. That equals y. So all this mess up here, I'm going to erase some of this mess so you guys can see it better. We did the Pythagorean theorem to find that this leg right there is 4,000, or the square root of 4,820. Now again, we had to find that because now we have this green triangle, and we can do the Pythagorean theorem to find this length, What's better than doing the Pythagorean theorem once? Doing it twice, right? So this x is one of the legs. The hypotenuse goes opposite the 90, and that's the 76. So 76 squared goes on the right side. The x squared and the root 4820 squared goes on the right side. So that's kind of why I wanted to keep it as the square root of 4,820, because when we square it, the radical just ends up disappearing. And now we're going to solve for x. So x squared plus, if you square this, you just get what's left underneath the radical, 4820. And that equals 76 times 76, which is 5776. Just about done. We subtract 4,820. So when you subtract 4,820, you get 956. And now we're going to square root both sides to get x all by itself. So x equals the square root of 956. If we have our exact answer, we can break this down into 4 times 239. So we could have an approximate answer just by putting that into our calculator, or as an exact answer, x equals 2 square root 239, because the square root of 4 is 2. Did we have units on this one? Yes, we did. Feet. So we'll be doing many more practice problems on the Pythagorean theorem when you get to class tomorrow.